This is a video on sentiment analysis on social media based on the paper Sentiment Analysis on Social Media by Federico Neri, Carlo Alberandi, Federico Capesi, Montserrat Coros, Thomas Bay. This presentation is presented by Aparna BN and guided by Dr. Jasma Balasangameshwara. In this session, viewers will be able to justify the importance of web in marketing arena, define sentiment analysis, illustrate components of semantic and knowledge mining systems used in sentiment analysis, and illustrate through a case study the concept of sentiment analysis. Now, let us start by understanding the need of sentiment analysis on social media. The web is a huge virtual space where people express and share individual opinions influencing any aspect of life. Reviews and ratings on internet are increasing their importance in the enhanced evaluation of products and services by potential customers. It is even becoming a fundamental variable in the purchase decisions. Consumers trust the opinions of other consumers, especially those with prior experience of products or services rather than the marketing company. The influence of the internet, especially through social networking, on people's purchasing behavior has grown over the years. Retailers who depend on the traditional store to drive sales have found that the reach of social media extends their visibility dramatically. A friendly, interactive presence on social networking or chat room can greatly improve the brand image and help the company gather extremely useful unstructured data about demand trends in a non-intrinsic way. Monitoring the social media activities is a good way to measure customers' loyalty, keeping track of their sentiments towards brands or products, the impact of campaigns and success of marketing messages, identifying and engaging the top influencers who are most relevant to the brand, product, or campaign. Social media can be seen as the next logical marketing arena. Currently, Facebook dominates the digital marketing space, followed closely by Twitter. Blogs, YouTube, and MySpace are less preferred despite obvious benefits these platforms offer. These factors have led to a number of companies offering sentiment analysis service in social media. Sentiment analysis and opinion mining are established fields of research, development, and innovation. The goal is always broadly the same: to know who is speaking about what, when, and in what sense. Sentiment analysis is the automated extraction of expression of positive or negative attitudes from text has received a considerable attention from researchers during the past decade. The popularity of internet users has been growing fast parallel to emerging technologies that actively use online reviews, sites, social networks, and personal blogs to express their opinions. They harbor a positive or negative attitude about people, organization, places, events, and ideas. Here we describe a sentiment analysis, a study performed over than 1,000 Facebook posts about newscasts comparing the sentiment for Rai 1, which is an Italian public broadcasting service, towards an emerging and more dynamic private company, La 7. The study results are mapped with observations made by Osservatorio di Pavia, which is an Italian institute of research specialized in media analysis at theoretical and empirical level. This study also takes in account the data provided by Auditel regarding newscast audience. The posts have been collected and analyzed using a content enabling system called ISIN Semantic Center. Now that we have understood the need of sentiment analysis on social media, let us now try to understand the issues that sentiment analysis will face. Firstly, given the never ending cascade of information on the internet in the last decade, the field of automatically extracting opinion has emerged, making it impossible to keep up with the flow of new information by manual methods. There are large bodies of work on opinion mining for English, but not for other languages such as Italian. Opinion mining can be applied at different levels of text, and polarity of words can change with respect to the phrase, context, domain, or meaning it is used in. For example, the word break will give a positive sense when used in a sentence such as breaking records, or it can even give a negative effect when used in a phrase such as breaking an artifact. To resolve this, word sense disambiguation must be done as a prior processing, which adds on to the overhead. Polarity expressed by words can be reversed within a phrase through negation. Now that we have understood the need of sentiment analysis on social media as well as the issues that sentiment analysis on social media faces, let us now try to understand the logical components of the system. The system, the semantic and knowledge mining systems used in this study is built on the following components. Firstly, the crawler. The crawler is a multimedia content gathering and storing system whose main goal is managing huge collection of data coming from different geographically distributed information sources. Its gathering activities are not limited to the standard web but also operate with other types of source like remote database, other web sources, Usenet news, mailboxes, file systems, and other proprietary source protocols. Even more complex sources such as audio or video files might be suitably processed so as to extract a textual based labeling based on both recognition of speeches, videos, and images. The next component is the semantic engine. This component identifies the relevant knowledge from the whole raw text by detecting semantic relations and facts in the text. Concept extraction is applied through a pipeline of linguistic and semantic processors that share a common knowledge. The shared knowledge base guarantees a uniform interpretation layer for the diverse information from different sources and languages. The extracted knowledge and information are indexed, making possible to handle fast semantic search. The next component is the search engine. In the search engine, firstly we talk about natural language search. Users can search documents by natural language queries expressed using normal conversational syntax. Reasoning over facts and semantic structures make it possible to handle diverse and more complex types of questions. Traditional Boolean queries, while precise, require strict interpretations that can often exclude information that is relevant to the user's interest. Next, we talk about semantic search. Users can search by conceptual keywords combined with Boolean operations. And lastly, we talk about semantic role search. Users can search and navigate by semantic roles, exploring sentences and documents by the functional role played by each concept. The next component is the machine translation engine. The system uses a combination of MT and CAT approaches, enabling the automatic translation of all pages of interest. It uses a dual feed recursive process where the reuse of translated text or the retranslation of text continuously improves the quality level. The next component is the georeferential engine. The system allows users to search for information in a geographical map, timely projected. Georeferential can be based either on sources or document contents. For example, users can navigate into a geographical interactive map basing on the newspaper's headquarters or on the towns mentioned in the news article posts. The last component is the classification engine. The automatic classification of documents is made fulfilling both supervised and unsupervised classification schemas. This application assigns text to predefined categories and dynamically discovers the groups of documents which share some common traits. Supervised clustering is the categorization model is created during the learning phase on representative sets of training documents focused on the topics of interest. Unsupervised clustering is documents are represented by sparse matrix where lines and columns are normalized in order to give more weight to rare terms. Each document is turned to a vector comparable to others. Similarly is measured by a simple cosine calculation between document vectors, which clustering is based on the k-means algorithm, which is sufficiently robust algorithm for web mining interactive applications. Now that we have seen the components of the semantic and knowledge mining system used in this study, let us now see how the system is used in monitoring the social media. Monitoring the social media happens in two steps. First is collecting the data, and second is navigating the data. Navigating the data happens in three substeps: search and cluster, explore the data in depth, and explore the consensus for last 7. Now let us see collecting the data in detail. Around 1,000 posts have been collected by crawling of Facebook. Only the textual contributions related to last 7 and Rai 1 news programs have been semantically analyzed and indexed. Now that we have seen collecting the data in detail, let us move on to the first substep of navigating the data, which is search and cluster. In search, users can search documents by expressing their interest by natural language queries using normal conversational syntax. As seen in the figure, when searching for, the audience wants a well-balanced newscast, which is given in Italian here. The system returns as a result all the documents talking about sobriety and moderation on news. This figure shows the efforts made by Last 7 to offer a well-balanced news program highlighting all the positive comments from Facebook. Moving ahead to clusters, clustering these results, the system identifies a group of documents dealing with users which follow the Last 7 newscast directed by Enrico Mantegna. Some other documents talk about the special care over sobriety provided by Last 7 newscast when treating the Italian politics. Moreover, other clusters deal with the new director Mantegna. Instead, other clusters deal with the slip of approval of Augusto Manzolini's news program that belongs to Rai 1, being too much factitious and dedicating too much time to gossip. A map shows the different clusters as differently sized bubbles, and meaningful correlation among them is drawn lines with different thickness. Users can search inside the clusters, giving a temporal or functional projection of main concepts they contain, or explore links among topics. An example: when exploring the map, the system suggests that many viewers have left Raivan having considered Augusto Manzolini too much facetious, giving to analysts and an automatic new perspective on cited facts. Going ahead to the second step, explore the data in depth. When navigating the space concept, the system suggests that free newscast is related to a normal newscast, which is in turn related to a factitious newscast to Augusto Manzolini, who is in turn related to sober to well balanced newscasts. The relations chart can be considered as a visual investigation component specifically designed to bring clarity to complex investigations. In fact, it automatically enables investigation information to be represented as visual elements that can be easily analyzed and interpreted. Let us now access the data provided by Osservatorio di Pavia related to the same period of time. The data produced by Osservatorio di Pavia are utilized by the Italian Parliamentary Commission on RAI. These data certify that TG1, the RAI 1 newscast, has dedicated more time to government and its supporting majority than any other news program. TG1 reserved to about 20% of the television space to the opposition parties. The rest has been mainly divided between government to about 45% and majority parties to about 15%. Moving ahead, we see that besides in April 2010 compared to April 2009, TG1, which is a rival newscast, has lost about 11.3% of its audience, having about just 5.9 million people, which is just 27.1% of the total share. In November 2011, TG1 reaches the bottom in share, having an average of 16.1% in audience. In November 2011, TG Last 7 exceeds its share records, having an average share of 14.6 in audience. The overall performance measure used on sentiment analysis used are recall and precision. In the tests, they are normally about 87% to 93% respectively. Now we come to the third and the final sub-step, which is explore the consensus for last 7. The system allows users to explore statistical time and frequency distribution for concepts taken in account basing on their parts of speech and semantic role. Adjectives, adverbs, nouns, and even sentences can be labeled as subjectively positive or negative or objective, giving indication about perception people may have about persons or facts. When analyzing the time projection for consensus for last 7, analysts can note that it is constantly positive apart for a few negative comments published in November 2009. Here we come to the end of the presentation. By the end of the presentation, we have understood the importance of web and marketing arena, a broad definition of sentiment analysis on social media, a detailed abstract of components of the semantic and knowledge mining system, monitoring the social media using the system, with an example where we compared the sentiments of RAI 1 to last 7. These are the references used for this study. Thank you.